Okay, good day. Today we can discuss the topic about assuming trial functions in finite element analysis. How can we assume the trial function? Why we need a trial function? In finite element analysis, we can discretize the component 1 into n number of parts. These elements are combined with each other. From this we can get the exact solution, but in FEA does not give any exact solution. For example, if I consider some curvilinear nature is available means I can imaginary draw. This hidden line is known as a linear trial function, but the true function is this curve. Okay, this is the term trial function we introduced in the finite element analysis. So we should aware about what are all the trial functions. We can introduce it into the finite element analysis problem. For example, if I consider the differential equation that is available with the finite element analysis problem. For example, I consider one physical phenomenon. That physical phenomenon has d square y by dx square plus y is equal to x. The boundary condition is 0 less than or equal to x less than or equal to 1. Likewise, it may has the boundary limits, but boundary conditions may be explained with y of 0 is equal to 0, y of 1 is equal to 1. Likewise, I can assign the boundary conditions with respect to the given physical phenomena. Or otherwise, the problem individually has its own boundary condition. Likewise means here, how can I represent this boundary condition y of 0, which can be represented as like x equal to 0, y equal to 0. Here y of 1 is equal to 1 means x equal to 1 and y equal to 1. Okay, which is the form available with the finite element analysis problem. Here you see the first boundary condition is y of 0 is equal to 0. The second boundary condition is y of 1 is equal to 1. Here the boundary values are differs. The first equation has y of 0 is equal to 0, but the second equation is y of 1 is equal to 1. So those are does not equal to same each other. So that this kind of function is called as heterogeneous function. When the boundary conditions are not equal means this boundary condition is called as heterogeneous functions. So how do we define the heterogeneous trial function? Let's see what is the trial function for heterogeneous function. Yes, which means y is equal to ax into x minus n into plus x. Here what is n? According to this problem, the minimum x is 0, the maximum boundary condition x is equal to 1. So that here I can write a into x minus 1 plus x, which is the form of heterogeneous trial function. If suppose already I told you y of 0 is equal to 0 as one of the boundary condition and y of 1 is equal to 1 is another boundary condition. If both are equal means how can we equal? Yes, how can we represent the boundary conditions are equal? Y of 0 is equal to 0 and also y of 1 is equal to 0. Here you see x equal to 0, y equal to 0 for first boundary condition. For second boundary condition x equal to 1 and y equal to 0. Here you see here y is equal to 0, here also y is equal to 0. So the first boundary condition is equal to second boundary condition. This case is called as homogeneous trial function, which is called as homogeneous. So that how can we select the trial function for this kind of homogeneous function, which is y equal to a into x into x minus n, which is the general form. Here the x value is equal to 0 and another boundary condition x value is 1. So which can be written as like ax into x minus 1, which is the trial function for homogeneous problems. After that, the boundary conditions may be written as not like y of 0 is equal to 0, y of 1 is equal to 1, but the boundary condition may become as like d y by dx of 0 is equal to 0 and dy by dx of n is equal to 0. Likewise, my problem has the boundary condition, means this kind of boundary condition is called as a differential order function. This differential order trial function can be written as y is equal to a0 plus a1 into x. What is the number a1? So that x plus a2, the second term, second parameter a2 and x square. After that a3 into x cube plus up to plus an into x power n. Likewise, we can represent the trial function for the differential order equations. These are all the problems which are comes under displacements. Okay, we can transfer the displacement of one element to another element, means we can utilize these three trial functions, which are homogeneous trial function, heterogeneous function and differential order function. But in structural analysis, we are having the beams. Okay, we are having beams. It may be a cantilever beam or it may be a simply supported beam. If we consider this cantilever beam, means the perpendicular load is acting, so that the beams has some deflections which can be represented as delta. So if the problem has deflection, means what happens with the trial function? If we are considered to solve the problem with the deflection, means the trial function y is equal to a1 into sine pi x by L plus a2 sine 3 pi x by L plus it may be exceeded its limits, boundary limits, but we consider only one term for solving the problem with a simple manner. So now you may aware about what is homogeneous trial function, which can be represented as like y equal to ax into x minus n. But we are having the heterogeneous function in our boundary condition problem, means we are having a trial function as like y equal to ax into x minus 1 plus x. And if you are having the boundary conditions as like dy by dx of 0 is equal to 0 and dy by dx of n is equal to 0. Likewise, we are having the boundary condition in problem, means we are utilizing the trial function as like y equal to a0 plus a1x plus a2x square plus a3x cube plus up to an into xn, which is the trial function for differential order boundary conditions. Similarly, our problem not only deals with the displacements, our problem maybe follows the deflection also. If my problem is the deflection, means we should utilize the trial function as like y equal to a1 into sine pi x L plus a2 sine 3 by x by L plus a3 sine 3 5 by x by L. Likewise, we can utilize the trial function for solving the problem. So the deflection problem utilizes the trial function as like y equal to a1 sine pi x by L plus a2 sine 3 pi x by L plus a3 sine 5 pi x by L plus up to what are the element we needed, we can extend that level. Now you may aware about how do we assume the trial functions in finite element analysis problem solving. Thank you all. If you are having any doubts, you may ask me through comment box.